Hello, welcome back. Today we'll learn how to convert a quadratic function from standard form to vertex form. So our goals will be just that, to convert from standard form to vertex form. Then actually we'll quickly look at an example where we convert then from vertex form to standard form, which we'll see is basically a very straightforward process. But first, let's look at converting from standard form to vertex form. So as it shows below, when you go from standard form, which looks like this, to vertex form, which of course looks like this. And we're going to do that, or below, from here to there. And we're going to use a form of pleating the square to do that. Pleating the square is a technique you may have learned to help you solve quadratic equations, and we're going to use a very similar version of that to help us convert from one form to the other. And we'll see it's not exactly the same process, but it's very similar to what you may have seen in solving a quadratic equation. So we'll explain how to do that. So first, let's go over here to the right and take a look at an example. Our first example. Actually, hang on, I need to make sure I add a few more pages here to make sure we have enough. Make sure I have more than enough. So let's go back to where I was. Now, let's look at our first example. Let's start with a fairly basic one first. Let's say our function is f of x is equal to x squared minus 6x plus 11. Now, so this is certainly in standard form. Looks like this. And we want to convert it and make it look like this form. So actually, I'm going to show what we want then is f of x is equal to a times x plus h squared plus k. That's what we want, this form. Now, one thing we can pick out right away, the a is the same in both cases. The a is the number in front of the squared term. So I already know that's going to be 1. That helps. We also have to find out what h and k are. So let's explain how we're going to do that. So remember, I'm going to put a little space here. But what we want out of this process is, for a here, we're going to put that our a is equal to 1. So x plus or minus something, and then plus something else. That's our goal. That's what we want to get to. Make it look like this. Now, how we're going to do that is once again a version of pleating the square. So first, what we're going to do is we're going to write this as f of x is equal to x squared. Let's rewrite it, minus 6x. Then we're going to put some space. We need to add something to complete the square. But since we're adding it here, we also have to take that same thing away from it. And so the plus 11 out here. We have to add, if we add it, we also have to subtract it. So that way we're not changing what the function is. If we don't subtract as well, we'll change what the function is. Now, let's find out what we have to add. So this is going to be the same number here and here. What we're going to do is we're going to take this number. It explains this. So a is not 1. Factor the a out. Okay, let's follow our directions here, which that wasn't the case. Within the parentheses, well, we're not using parentheses here, but we'll see that in the next example. Complete the square. We'll write a perfect square trinomial as a binomial squared, and then combine the constants on the outside. And then the quadratic function should look like that. So let's see how this process works. We're going to take this number, which of course is -6, and divide it by 2, which is -3. Now, what I'm going to do then with that is I'm going to square that number and put it right here. Okay. Now, once again, so I take this number in front of the x here, including its sign, divide it by 2. This is -6 divided by 2 is -3. I square that and put that here and here. Okay. Now, also, since I know that, it already tells me this is going to be a -3 right here. Okay. So, continuing, let's see what I have now. I have x squared minus 6x. Of course, -3 squared is 9, so I have plus 9 minus 9 plus 11. Now here, you want to kind of resist the temptation to just combine things the way they are. Otherwise, you'll be right back where you started. And what this is going to be, we don't have to factor it, but if you did factor, So if you factor this part right here, what you'd have then would be f of x is equal to, you factored it, this would give you x minus 3 times x minus 3. And then over here, we still have this negative 911, which we can now combine into plus 2. And if you tell, then x minus 3 times x minus 3 is x minus 3 squared. And that's going to be plus, now we just have the plus 2. So this becomes this. And so finally, f of x is equal to x minus 3 squared plus 2. So this is the same quadratic function, just in a different form. Okay. Now, if you wanted to check, you can actually kind of reverse, take a look back and follow your steps backwards. We should get what we started with. So if you take this, you write this as x minus 3 times x minus 3. Remember, powers don't distribute. Okay, if you FOIL or distribute this, you get this. Okay, now here it might not be as clear what you'd have. Well, actually, right here, then you have this, then plus 2, which would give you on the outside, you have x squared minus 6, and you have the plus 9 and plus 2 to have plus 11, which is what you'd have right here. Okay, now you can always, to verify this is true, you can always graph this function and this function, and you will see that they both have exactly the same graph. Okay, good. Now let's do number 2. And actually, I think I'm just going to start number 2 on its own page. Now let's take a look at this one. Number 2, we have f of x is equal to 2x squared plus 4x minus 3. What's new this time is we have a number in front of our x squared term, something other than 1. This time our a is going to be 1. Okay, so 2. Already know what that is. So like in the other one, we want to get out of this at the very end. I'll put it down here. So what we want is going to be 2 times x plus or minus something squared, then plus or minus some constant out here. Okay, now what's different this time is we're going to follow this. So if a is not 1, that's the case here, factor a out of the terms and variables. So that's going to be our first step. So f of x is equal to, we factor the 2 out. Okay, and so we factor that out. Remember, essentially it means we're dividing. So dividing this by 2 gives us 1. Dividing this by 2 gives us 2. So plus 2x minus 3. Now, within the parentheses, we're going to do the same thing we did before, is we have to add and subtract something. So x squared plus 2x plus something, then minus something, and we have the minus 3 outside. Now, at this point, the process is the same. We take this number right here, which is plus 2, divide it by 2 is equal to plus 1, and that's what we put right here, and here squared. So it's plus 1 squared. And now we know this is also going to be a plus 1 right here. Okay, so continuing, let's see what we have next. And so we have 2, let's just write all this out, x squared plus 2x plus 1 minus 1 minus 3. Now, once again, resist the temptation to just combine these. You'll be right back where we started here. What we want to do now is actually distribute. We distribute the 2. And distribute the 2 to these 3 in 2 parts, to here and to here. Okay, now what I mean by that, with the next step, if I distribute this 2, it's going to be 2 times x squared plus 2x plus 1. And then I'm distribute the 2. So I'm distribute the 2, these 2 terms, I can do this. You can distribute it however you want to, as long as it's valid to distribute. And then here, I have a minus 1. This means minus 2 times 1. Okay, so distributed the 2 to these 3 together, and then just to here. Okay, and minus 3. All right, we're getting closer. So now if I factored this, what I would get would be x plus 1 times x plus 1. Of course, this is -2. This is -3. And so, if you see, then x plus 1 times x plus 1 is x plus 1 squared. Now here I have -5. So my function in vertex form is 2 times x plus 1 squared minus 5. So that is the same function as this, simply written in a different way. Once again, if you graph both of these, you will see they give you the same graph. All right, let's do one more of these. This time let's do one that involves a decimal, because that may look strange at first, but as we'll see, it's going to work the same way as the one we just did. So we have 0.2x squared minus 1.6x plus 1. Okay. Now here, our a, the number in front of the squared term, is going to be 0.2. And so like in the past ones, what we want to get out of all this, we want is going to be 0.2 times x. Then in here, we have plus or minus something here, and then plus or minus something out here. Okay. So once again, I'm going to factor, as I did in the previous one. This is not 1, which is not. I'm going to factor this out. Now, that may look a little strange at first. We'll see how that works. So I pull out the 0.2, and what this is, remember what I'm doing essentially is dividing both parts by 0.2. Okay, divide this whole thing by 0.2, I just get x squared. I'm going to divide 1.6 by 0.2. If I do that, I get minus 8x. Okay, if I divide 1.6 by 0.2, I get minus 8. Now, if you're unsure, multiply that back through. 0.2x squared is 0.2x squared. 0.2 times 1.6x is negative 1.6x is negative, sorry, 0.2 times negative 8x is negative 1.6x plus 1. Now, at this point, my process is basically identical to number 2, the one above. So I'm going to write this again. So x squared minus 8x. Then once again, I have to add something inside the parentheses and take it away inside the parentheses. I still have the plus 1 out here at the end. Okay, and this one once again works exactly the same way. I take this number, okay, take half of it, so negative 8 over 2 is equal to negative 4. And then that's what I'm going to square here and here. So negative 4 squared. I'm going to add it and take it away. Negative 4 squared. So once again, I still have f of x is equal to 0.2 times x squared minus 8x plus 16 minus 16 plus 1. Once again, as I said, resist the temptation to just combine these together. Otherwise, you get this again. Now, also, once again, I'm going to do is I'm going to distribute the 0.2 to these three terms, like I did in the previous one, and also to this one. If I do that, I have f of x is equal to 0.2 times x squared minus 8x plus 16. And then a minus right here, 0.2 times 16, then plus 1. All right. Then let's see what we have after that. So if I factored this, oops, I forgot to mention, of course, then once you get the negative 4, we took this divided by 2, made it negative 4. That's, of course, what we put right here. If you even didn't see that at that point, if you factor it, you'll see it. If you factored this, it would be x minus 4 times x minus 4. And here, 0.2 times 16, let's find out what that is. It's actually 3.2. Sorry, minus 3.2 rather. And plus 1. So now we can write this. This times this is x minus 4 times x minus 4 is x minus 4 squared. Negative 3.2 plus 1 is negative 2.2. And then finally, I'll say so. It looks like a 5. So my function f of x is equal to 0.2 times x minus 4 squared minus 2.2. And once again, you can check and make sure that's the case. You graph both of them. Okay, let's do one more example. And this time I think I can squeeze it in right here. So this is, let's convert the other way. So I want to, let's do an example. So I want to convert, make up an example here. F of x is equal to, let's say 2 times x plus 1 squared minus 3, okay, to standard form. Now, most of the time, would be very little reason to do this. This is probably a better form to have it in, but in case you want to do it, it doesn't require completing the square. All it requires is just multiplying. So if I do that, then let's write this down again. Write our function down once more. 2 times x plus 1 squared minus 3. Okay. First, remember, you can't distribute powers. So this is not x squared plus 1 squared. What this has to be is going to be 2 times x plus 1 times x plus 1, then minus 3. Okay. Now, these I'm going to FOIL or distribute however you want to multiply them. If I do that, I'm going to have 2 times, you'd have x squared. The first term is x times x is x squared. My outer term will be x times positive 1 is 1x. My inner term will be the same thing, 1x. So if I combine those, that's going to be 2x. And then my last term is plus 1 times plus 1, which is just plus 1 minus 3. If I can squeeze all this in. So distribute this, the 2. So 2x squared plus 4x plus 2 minus 3. And so finally, I'll just come right over here and put it somewhere out of space. So f of x is also equal. I can also write it as 2x squared minus 4x and then minus 1. So once again, these are the same. So you can convert from one to the other, and it's certainly easier to convert from the vertex form to the standard form, although it's probably more rare that you would do that because this is kind of overall probably a more useful form to have it in. So what we've learned today then is how to convert, primarily how to convert an quadratic function from standard form to vertex form. Thank you. Have a good day.